So that's evening in Europe, it's noon in the US or afternoon, and it's probably early morning in Australia. So welcome to this third day DevDays day, and this evening with a session on mapping CDA to FHIR. My name is Gustav Vella, I'll be your host, and our speaker is Oliver Egger. Oliver is a software engineer and a computer scientist hailing from the Swiss Institute of Technology, ETH Zurich, and he's the founder of ADIS.org, which offers consulting workshops and implementation services. He's one of the most knowledgeable people in the growing community of people dealing with the FHIR mapping language, and I'm really happy to pass over to Oliver. So Oliver, we can't. Yeah, great. Now I can hear you.
Hi, Gustav. Thank you for the introduction. Can you see my screen?
Yes, I can see your screen.
Perfect. Okay. Yes, welcome to my talk. I think we can skip the introduction already. Thanks a lot, Gustav. I'm not sure if you have seen on today's plenary session the ticker going through. They opened a museum for CDA in Vienna, so I had a big laugh. So we're from Switzerland, maybe have also a CDA document which we could sponsor for this museum. I'm not sure if our colleagues in Austria are that happy about that too. But yes, so CDA is a quite old HL7 standard, 2005, but here in Switzerland we have also projects running it, and we face the challenge how to come to the FHIR world, or the industry is saying we want FHIR documents, we don't want CDA documents, but we have already specs written in CDA. So the objective of this tutorial, which I would like to show you, is the relation between CDA and FHIR documents. Approaches to map CDA to FHIR and back. What that has to do with the CDA Logical Model, which is a key concept when you use the FHIR mapping language, and then how to use the FHIR mapping language to convert from CDA to FHIR and back.
Great.
So when you're talking about document, and this is independent of the standard, you have different characteristics. So you can store documents, you have a stewardship around it, somebody has written it, authenticated it, wholeness, it's human readable. And they started also within the HL7 community. They developed this clinical document architecture. You see here on the left letter, a referral letter, where you have some data about the patient, metadata, and they structured it with the HL7 version 3 standard. So here to the right, you see you have a clinical document tag, then you have a structured body, and you have this structured already also on different levels. So it's one part the metadata, header data, but then also a body which could be structured with clinical statement entries down to, for example, a medication or a lab value, similar what we do in FHIR. And the equivalent concept we have also in FHIR. So FHIR is not only the REST API and the resources concept, but you can also use it for other architectures, like if you want to create documents or exchange documents as a whole and not only as the individual resources. In that way, we have the same principles actually as a CDA document, very familiar. It looks a bit different. So a document is a FHIR bundle resource, and this FHIR bundle resource has as a first entry a composition resource, and in the composition resource we have then different sections which are possible, the similar concept like we have in CDA, additional metadata, and out of the section we refer then to the different entries in which are then like a medication list or some other resources where we have then the structured data. So in principle, we have the same things. We have a clinical document focus. We have this human readability approach. It differs in the level of structuring. So in the CDA model, you have these clinical statements, which are more coarse than we have the variety in FHIR resources. So that's already a huge difference. Then these standards are very general. So with the CDA document, you can actually describe any document, and equivalent with FHIR documents. So what you need to do is you need to profile it down, or in the CDA world, it meant writing templates that you know what kind of meaning a specific medication has, a specific allergy has. So in that way, this makes it then also a bit difficult to mapping, because just map a whole CDA world to a FHIR document world as such is not possible. The markup is different, so CDA has its own markup, but this can easily transform to HTML. FHIR documents has XHTML as a markup language, so there are some small differences. And when we look now at this mapping, so there are different levels of mapping possible. So the first is quite easy. So when you have a CDA level 1 document, which is just metadata and text, you can also map this to a bundle with a composition. So this is, you have to know a little bit how to do that, but this is not very complicated. On a level 2, it gets a bit with the sections when they are coded, that's also easily done. And on the level 3, where you have these different structured entries, it gets more difficult. So I think, and in the end, there are some approaches which are looking at from a model-based view, but I think in the end, you really map then one template to another. When you know the source template, you have to write explicit mappings to the target entries or profiles you want to do. And I think the reshare is not highly possible, but this we'll have to see. So in the end, I think you go down to a template level mapping. You have some first indications of this mapping directly in the specification. So if you go to FHIR composition mappings, you have an entry CDA, and you see already which kind of metadata maps already approximately to which part of the clinical document. And now the question is how we want to map this. So there are different mapping strategies possible. The first is actually to do no mapping. So you can use this CDA and treat it as a binary document and just reference it from a document reference. But if you are really interested in the data inside, it's probably not the best approach. So XSLT, coming from the NixSL world, was used in quite a few projects already, that you can make transformations written in XSLT. Then there were HL7 projects out of Argonaut and the CCDA consolidated CDA projects, which started to describe first mapping or mapping to profile approaches. And then came the CDA Logical Model in existence, which allowed to use the FHIR mapping language. We will dive deeper inside it afterwards, but there are also other approaches. Just before, Doug from Microsoft was showing their approach, how they use their tooling to convert CDA to FHIR. Also, Google has a transformation engine which they are working to convert different. So the FHIR mapping language is not the only approach. I will dive in deeper here, but there are also other approaches. So there are these mapping approaches. We based on the existing mappings on the CCDA mappings, adapted them to our usage. They are all available. So if you want to peek in, this is the GitHub repository where you can use this map and use the transforms if you want to. The FHIR mapping language itself is also part of the specification. So it works in that you have a formalism, you describe maps where you describe how one tree can be related to another. There is a tutorial coming with it, and the nice thing about this is when you write such maps, you can convert them afterwards to a structure map, which is a FHIR resource itself. So you can afterwards distribute your maps in implementation guides. Other people can work on it and can then execute also these maps. So when we look at this in this CDI context, we have a CDA logical model which describes us how a CDA looks in the FHIR world. We write then the maps, and then we use a mapping engine, and this mapping engine can then convert the CDA to FHIR or back, depending how you write the maps. So what is this logical model? So FHIR has the possibility that you can describe arbitrary input or models with FHIR itself. So you can describe how a CDA document is looking in the FHIR world. And you do that in that you create such a logical model, and afterwards you can use these logical models as a base for describing the maps in the FHIR mapping language. And these logical models are actually structure definitions. So you define with structure definitions your structure, how this is, what kind of nodes you are, what is allowed as an input, what is the data type. So the restriction is it needs to be FHIR data types. So what is actually mostly this basic standard data types, but then you can describe your tree-like model. And this is not only done for CDA, you can actually use it, for example, also there is, I think, one in the works for version 2. You can take your basic XSD schema from another project and do this transformation to a logical model. So Graham presented at the DevDays in 2016, quite a while ago, this his work on this logical model. This was then further developed, and we have now an implementation guide which defines the whole CDA model as a logical model. So if you are familiar with CDA, CDA has its own data types, V3 data types. So all these are represented in this logical model. For example, you have the any data type, which has just a null flavor. And then this is the differential. So this is a structure definition describing the any data type. Then we have the next data type, a concept descriptor, which is derived from any. And this is then building in the differential the additional things in addition, which we have now in the logical model. And goes further and further. So we have defined this for all data types, and then you have all CDA classes also defined as this logical model, so that we have a complete description of the clinical document, and looks like FHIR actually. So we have all these different things inside. So, but this is just a logical model. This gives you no API for using it. The data types are equivalent to FHIR. You have also no concept of FHIR resources in that logical model. This is really the CDA document. The nice thing about this, and if you have also another project and you create this logical model, you can use that now also for validation. So you can feed the HL7 FHIR validator, the CDA model as a package, and then you feed him directly the CDA document, and now he executes all the rules against from the logical model, if the structure is correct, against the CDA document. So this gives you also a way to work with the standard FHIR tooling and work with your legacy CDA documents if you are interested. For our talk here now, we are more interested in how we can now use the FHIR mapping language to write these maps, so that we get this mapping engine feeded with our maps, can use this logical model to transfer this information. So what you need to do this, you need a mapping engine. So there are different mapping engines available. So one is the Java, in the Java reference implementation, which I think Graham developed, or not think, so he developed it. So this is also part of the Java validator. You can execute these mappings. This can also be exposed. So for example, we use the same reference implementation from him to do this as a service. But there is also from the FHIR guys and from Gustav's company, Helix, they have written a C# FHIR mapper and introduced in their product. So you have also the mapping capability in the .NET world. And there are some other projects also coming in that you can do some JavaScript mapping. So this is quite coming a bit maybe slowly, but we get more engines not day by day, but maybe month by month. And we have also some tooling support. So there is a VS Code extension, also from Helix, that you can have a nice visual representation. So you have to author these maps. What you see here on the bottom is such a very basic part of a map of this FHIR mapping language. So you define groups where you define the mapping from a source to a target. So this would be here now the source, which is the organization in the CDA world, and the target, which is the organization in the FHIR world. And then you define define the different rules how this should be mapped. So in this case, the ID in the organization ID is mapped to the target identifier, or I map the name to the target name. I map the telecom address to the telecom address. You see already there are some differences here in the naming of CDA and FHIR, but the structure itself aligns actually quite good. So you write these maps. You can do this in this textual description, and then you need a service, or you can convert this to a structure map resource. I just showed it here out of a REST client where you just execute this. So you have here your textual description. You can do this, use a script to upload it, and you get it then back from the server. You can also use Postman or whatever tooling for this, or integrate it maybe once in a future VS Code extension. And then you have that map available. And the second part now is if you want to execute that map, FHIR defines a transform operation. So on a structure map, so you provided the source, which content you want to transform, and then the operation returns you the result. So in that way, we feed him here now this clinical document. We make this, post it to this structure map, transform operation. You specify here the map. You send him here, we cheat a little bit, we say it's FHIR, but actually it's CDA. We feed him here the CDA document, and the response here back is the bundle, which we have then transformed by this with the mapping engine. So the origin of this endeavor was because we have different specification in the Swiss e-medication part. They are based on IHE pharmacy, and we have the representation, and we wanted to do now mappings, or we had to do mappings between the FHIR profiles we developed, which are an equivalent or should be transmitting the same information as the CDA, and we wanted to map in between those two parts. So these maps we provide also in a FHIR implementation guide. So you can distribute them the same and use it actually also. So they are now specific to this document, but for the base maps, which just maps, for example, a CDA to a bundle or a bundle to a CDA, you might reuse it for the other things. You can make maybe some inspirations. What we liked very much is if you do both mappings, so you can also check that you do, if you do it in one way and back, you can check if you get back the same result, because that's something also quite difficult. So it's a very nice test-driven approach when you can automatically do two translations and look that you get back the same, and you can do validation on the source and the target, so you know that all the things should be correct in the end. So to give you a bit more deeper look how this language look like, I have taken 2 free examples how this would look like, this representation in the mapping language. So in CDA, for example, we have a code, this coded equivalent in this logical model we have seen here before. So we have a code and we have a translation of this code. So the base code is Lowing, the other code is Snowmade City, and we want to have it in a coding data type in FHIR where we have just the both codes listed below. And then that's then the map description. So you define a group which is here called CE2 codable concept, which takes as a source the CE. This is now the reference to the logical CDA model, and which goes to the target codable concept, which is the FHIR complex data type representation. And now all these rules are run through. So if you have an original text, which we don't have it, it would set the codable concept context. If then it goes further, so we have here the source. So this rule catches, it says, yes, create me a target coding as a coding. And then, so this is the alternative of calling another group. It goes into these statements here. Then it says, yes, set me the code and set encoding code equivalent, the casted version of this code as a code. Then the code system, and here you see the first things, what you have to do a bit more in the mapping. In the CDA, we have code systems identified as OIDs. Here, this is the low anchor OID. In FHIR, we prefer the URL or URN of the lowink.org. So, and here you can use now a concept map. So FHIR has a concept map resource, and you can now use within the mapping language with a translate operation that you can translate these OIDs to another one, to this URN and equivalent the other way back. And then for the display name, we just set this as display name. And then what you do in the FHIR mapping language is you go now a level deeper. So we go into the next 3-element insight. This is this translation, which is the SNOMED CT equivalent of this lowink code for this thing. And then if we catch a translation, then we go inside here, we create another coding, and then it's set actually to the same values. And this goes then actually, you do this now by all the metadata. So here is the example where you map the patient role to a FHIR patient. So this goes first for the complex data types, goes then down, and you see you have another one where you translate the administrative gender from the CDA world into the FHIR world. And for the whole CDA document, they are structured in sections, and we have seen they have this templates ID, which identify what kind of section it is. We could also use the code. In this approach, we use now the templates ID. Then we say just for each section, if we catch that section, and you can make clauses to go catch specifically this section. So what you see here after this where clause is a FHIRPath expression. So if you're familiar with FHIRPath, you can write very quickly also now on the CDA document, actually, you write FHIRPath expression and catch here. If this section has this template ID, I go into the group which handles me the mapping for this section. And when you are then in the section, you have to handle all the level 3 entries. So a section, for example, here in the medication, in the CDA world, this is then an entry which is a substance administration. We catch here also if it's the correct template we want to translate. And then we have to create in FHIR a new resource. This is a medication statement in our case. So we create a new bundle entry. We create this resource. We assign it a UUID. We put the full URL to this UUID, create the reference to it. And then we go into the content module itself and set there afterwards the different values. So I hope this has given you a quick glimpse of what is possible with the FHIR mapping language and how this can be used. So what we have seen now, specifically to the CDA FHIR document mapping, it fits very well for the FHIR mapping language approach. I mean, there are very different approach how to do mapping, but if you have some similar data like CDA and FHIR documents, it fits quite nice. You have this textual representation, so you can share the maps, you can make pull requests on it, you can discuss on it, and then afterwards you can distribute it with an implementation guide, which I think is a very versatile addition. And it's closely aligned to FHIR. So if you are familiar with FHIRPath or concept map, that's the nice thing. Honestly, that's also on the other part of it a disadvantage. You are locked into the FHIR ecosystem and locked into the FHIR tooling you have available. So you have not all the other tooling which you might be able to use with other mapping approaches. There are some other things. So it's quite a steep learning curve for this mapping language. It's not quite easy to understand for the first things, but I think if you figure it out how to work, it's not that difficult anymore. And there are some limitations also, that's maybe my personal opinion, but in the API and syntax of the FHIR mapping language. So you have some kind of API, but sometimes you would like to do a little bit more or have some additional functionality, and then you are a bit limited. If you are interested in these different topics after today, I invite you to join the different channel discussion on Tulips. So there are discussions about CDA or CCDA, but there are also around the CDA to FHIR or specifically also for the mapping framework itself streams. So go there, post questions, and hopefully there's somebody who can answer your mapping problems or mapping questions. So that's about what I wanted to show you. I hope you have seen how the CDA and FHIR documents are related. I mean, actually they are standards from the same organization, so it's would be a pity if that could not be mapped between each other. There are different mapping approaches. You can use this logical model concept also to use with CDA just for validating it. And you have seen how we can use the FHIR mapping language to convert from CDA to FHIR and back.
Great.
Yeah, thanks.
Yeah. So thanks. That was a really good, clear insight, and I definitely agree with those limitations you mentioned. Pain shared is half the pain. So I'd like to remind the guys that there is a poll going on what language or technology do you use to map. The answers are really interesting. So I think I can read. So there are a few questions. So the first, so I've got a question here by Ms. Kay Dolan. So she says, if you were on the previous CDA to FHIR, you may have seen this question. How are you handling the fact that there is context conduction from the CDA header that may be missing in the entry, but is needed information, example, performer, author, etc. Items important for provenance.
Yeah, that's a very good question. And actually, I heard it also in Doc's session. And in our case, you see it up in the end of the map. So actually, FHIR has no context conduction principle. What that means is if you create an observation, for example, and you have to set explicitly the reference to the patient. And in CDA, it was like this, that the observation is automatically assigned to the patient, which was maybe defined in the header. And we actually, since we are in a document context or in FHIR, we wanted to have this also, so this context induction, and then you have to write this explicitly in the mappings. So I'm not sure if I can show it here by hand, but in the end, what we do is we generate in the beginning the patient, and then we trickle down that patient to every resource which needed. We stopped here at the author. So in our project, the author was not that important at the moment. So I think we didn't context conduction of the author. But yes, you have to handle it manually, and you have to, that was something which was done in another approach in CDA. And if you want to have it in FHIR, you have to make this mapping explicit.
Okay, so then we've got another question. So that's dealing with, so let's say if you have difference in cardinality between CDA and FHIR resources, how would you deal with that?
I would create multiple resources. So if you have differences,
specifically authors, performers, authors or performers.
Okay, so I mean, in the end, if the cardinality is fixed in FHIR to 0, 1, which is very rarely the case, you need to create an extension. So we rarely had this case until now, but then if you cannot, if you're coming from 1 to n to a 1 element, I think you have no other choice of creating an extension for that. So, or at least I'm not aware of any other possibilities. But most often the basic FHIR specification is very general. So I hope that would not be too often the case. And the other way around, if you have then, I mean, mapping from CDA to FHIR is much simpler because you are less restricted by the model. Going back the other way around, you have to limit your FHIR model what you can represent in CDA, honestly. So that's the challenge we have a little bit, perhaps in the future, because if the FHIR model evolves, it has much more freedom than the CDA model. So we would need to, if we have still to support both, we would need to look how you could represent that in CDA.
Okay, so I have one question which is rather got to do with CDA in practice. So mapping becomes really complex if you have one to many, many to one mappings. So how does it really look like in practice in CDA to FHIR?
So in CDA to FHIR, I think it's not very complicated because the only one-to-n relationship are, for example, this entry relationship you have in these entries.
Yeah.
But these are not very complicated. So
great. Okay, so that sounds promising to try that out. So I think we're sadly on time. Let me just check. So we, am I right that we're on time? I think we're over time, right? Aren't we? Just give a quick check. No, we actually do have some. We do have some time left. So that's really great. So then another question which I do have is this relationship between structure definition and logical model. So it's sort of a bit difficult to find. So in principle, the logical model is a specific type of structure definition, right? If I understood you well before.
Yep.
So you just select the proper attribute. So that was always quite confusing at the beginning. So I don't know if you would like to touch on that exactly in more detail. So yes, if I'm not mistaken, it's the kind element, right? And then you select the code type, you select the type. So you have 4 types: primitive, complex, resource, and logical, right?
Yeah.
So that's how you use it.
So the part where the logical model described in the FHIR spec is actually very short. So
yeah.
So you see, this is all the part where it's described. Jose has just mentioned it also in the talk before. It could have some, he would propose some additional descriptions, because you can use logical models, I think, quite in a lot of context. If you have, for example, want to describe your, not just your data model, if your data model is not FHIR, your source data model, you can also describe it with logical models, and then you have the base for the mapping. So I think it's quite powerful, and the description is not very deep, but you have quite a few examples. So for example, for the CDA Logical Model, you can have a quick look inside how this look like. So this is the, I hope the CI build is mentioned here. No. When you look at the input, so which we looked at, for example, the CE data type we looked before. So this is now the structure definition, and it's like a regular structure definition. I think they also added now support for logical in models in Sushi, that you don't have to write XML or JSON, but you can write your shorthand to create logical models. But in the end, you define a structure definition, and what you do is, because you're a logical model, you are a specialization. So you add something that, on a base definition. So in this here, it would be the CD, and the CD would then be derived from the CE, and then you add the different elements you have. So if, for example, here the qualifier element is set to 0, so maybe I go to the CD, that's a better example.
Great.
So you have here the code element, and here you see you have a representation. It's an attribute. So it's in the XML world, it's not in this value element like we have it in the FHIR, and you say which type it is. And so you can assemble your data types, and then you have it available as a logical model.
Great. I think that really answers the question. So in the meantime, we have another question. So one's got 2 upvotes. I really like this question. So could you give example situations that the FHIR mapping language would struggle with due to its limitations, or in general, expand on its limitations?
So it's difficult to say. So I think if you have not data probably which is in trees and which you want to map strictly from one format to another, I think there are some limitations. So for example, if you have a CSV file and you write, I mean, you could write a general logical model for CSV files, then it's easy. But otherwise, then you would first write kind of a logical model and a parser, and then the FHIR mapping language. So that gets quite a bit complicated. Otherwise, and then limitations maybe. So we don't have yet a lot of performance experience yet. So maybe Gustav, do you have already some production experience on how good it works, the FHIR mapping language? So
yeah, let's say we do quite a lot, so that's performance-wise that works out. I think in general, if you have complex logic in your maps, that makes them really unreadable and really verbose. So then you're always tempted to do something. You'd actually love to do something, some things with extensions, as you wish you had some extensions which were, so the mapping language is more like a declarative language, and you'd love something like to have to shortcut with procedures. So that's, so I'd say if you're probably acquainted with Prolog or declarative languages, then you'll feel at home with the mapping language, or if you've done XSLT before. But performance-wise, it actually scales quite well. So we actually have one other question. I wanted to try and get as many questions by the audience as possible. So there's a good question. Are there any best practices of the FHIR mapping language? I find myself writing similar duplicate rules sometimes and wonder if it could be done more effectively.
Yeah, so I experience a little bit the same, honestly. So you have certain problems which you solve the same way, and you suddenly notice, oh, I already solved that once again. There is a little FHIR tutorial besides the spec, which documents a few approaches. I think maybe we could open on Confluence, or I don't know where, a page where we could document maybe a few examples or snippets or something like this. So I think that's a good idea. So somebody is interested to contribute, get in contact with me. Maybe we can open such a space where we could put such examples inside. There is also, during the HL7 connectathons, there is a FHIR mapping language track. So most often, so if you want to exchange with peers, then that would be also a possibility. And maybe once we try to update the Confluence page to give a more detailed description of the FHIR mapping language, we're working on the FHIR tutorial. So maybe like a cookbook for FHIR mapping language would be a good thing. And I mean, honestly, if you say of limitations a little bit, the community around the FHIR mapping language is not huge. And I don't know, Gustav, how you see it. Also at the FHIR Connectathon, there are a few people interested. We hear from projects, but it's not like that hundreds of people are doing FHIR mapping language. So honestly, it's a quite a niche at the moment. And we have to see how this develops a little bit, also if the community gets bigger.
Yeah, that's a good point. So I think that it's good for formats which are syntactically and semantically more or less normed. So V2, CCDA, CDISC, and FHIR to FHIR. And yeah, as we said before, it's presently quite tedious sometimes when you have complex logic. I think what's really tempts you to continue trying and keeping up with that is it's the only, as far as I know, open standard for mapping, where you could, so you have this promise of sharing maps and maps being runtime independent. So I think that's sort of what keeps most of the people in the community going sometimes and trying this out. So
I think one thing also which we don't have to forget is there has been a lot of work done for so each resource. Maybe looks at the practitioner. You have here a mappings tab. Now here there are free conversions. So they were working on writing maps from version to version. So you have here the maps which describe if you are working with FHIR release 3 up to release 4. So you have here the maps how this can be converted up and down. So I mean, there are certain limitations. You cannot map everything, but I mean, this is a huge also resource. And if this is continued, then afterwards to R5, you have also a possibilities how to map directly on a server between those different versions if you have to.
Great. So maybe we have time for, I'm just checking whether we actually have a few other questions. So we've got a question here. Just checking. These are all answered. So I've got this question here. So in condition resource, you have a 0-to-1 recorder, which would correspond to author in CDA. In a HIE, you might have the same condition with many authors. I'm not sure what, do you get it?
So that would mean that, so you have a condition which has
0-to-1 recorder, which would correspond to author in CDA. In HIE, you may have the same condition with many authors. I'm not really.
So in the end, I think then you just, you would need to add an extension here. I wouldn't see another option.
I would tend to agree with you. Yeah, so I think those were the questions. So if we look at the polls, the results of the polls, what tooling you're using, that's quite interesting.
It's
So
Python was before, huh?
There's a lot of Python. There's some XSLT. There's the FHIR mapping language and .NET API, C and Func. That's interesting. So that's probably the same. And then there's somebody who says they're still out exploring. So I think that's wraps it all up. We're not sort of, there's quite some popularity with the mapping language growing, but it's still not the most popular. So I hope that this talk actually gave some insights and will make it a bit more popular. So thanks a lot, Oliver. Great presentation. You did actually take more questions than you expected. So I'd say have a good evening and remaining dev days.
Thank you. Thank you, Gustav, for the
And see you all
moderation.
around.
Thank you.
It was a